all that good stuff. Today we're looking at a special case of functions, specifically those linear functions. So if it is linear, then it's of the form y equals mx plus b. We might see it in function notation. Like I said yesterday, if it's function notation, what replaces the y?
The f of x.
So you might see f of x equals mx plus b. It means the same thing. The graph is a line. What does the m represent?
That's slope. Oh my goodness.
And what's the b?
Y-Intercept.
Yes.
Look at us go.
I am so proud of you guys. See, you said you didn't learn anything last year, but you did.
We learned this freshman year before.
See, you've learned. All right, makes my job easier. I don't need to teach you. You already know it all.
Oh, okay. Still need to teach.
Okay, let's look at this. So, if I asked you to graph this. So, I'm sorry, I am not as nice as Mrs. Keller, and I don't print graph paper.
So we have to draw a graph in the paper?
But I'm going to draw a graph too. We can do it.
I might just draw 2 lines and then guess.
Yeah.
I used to do that on Miss
We
Carr's
just-
homework so much, she gets so mad.
Oh, that's all we have to do?
Okay, what do we plot first?
The 7.
The 7. So on my y-axis, I've got 7 tick marks. My slope is -3. So how do I graph that?
How do you do left
It's-
3 up right?
No, it's
down 3 right 1.
Yeah.
There.
Rise over run. So down 3, right 1. You could also go up 3 and left 1. That would work. You need at least 2 points. And then
Just
hopefully,
2? Only 2?
yeah, you can do more if you want, but you only have to have 2. And then use a sheet of paper or something to help you draw a semi-straight line, and we're good. So there's our line.
Beautiful.
Your line's not very straight.
I know, don't judge me.
Do we have to use rulers to make the lines look straight?
Just try. If it's reasonably close, then I'm not gonna. Clearly, I can't judge. Look
If
at
it
mine.
wasn't straight, Miss Keller counted it off.
Yeah. She literally counted so many points off of my
Well,
test.
it needs to be somewhat straight, you know, if it's
No, like, it
curved.
would be perfect.
So what's my domain here?
All real
All
numbers.
real numbers.
Okay.
Yeah.
And then the thing you missed yesterday,
Infinity.
we used a new notation. So you'll see this in the notes in the video, but we use what's called interval notation. So instead of saying like -2 is less than x is less than or equal to 7, we give a starting point, comma, and an ending point. Since this goes forever in the negative direction, we call that negative infinity, and goes forever in the positive direction, so that's positive infinity.
Okay.
Then we use parentheses or brackets. If it's not equal to something, we use a parenthesis. If it is equal, we use a bracket. You can't equal infinity, so it always just gets parentheses. The range. This end's going down forever, and that one's going up forever, so that would be same thing. This will be true for every line except horizontal and vertical lines. So if your line is not horizontal or vertical, you know from the beginning your domain and range are both negative infinity to positive infinity. Okay? Do we need to do another one like this? Graphing this line? You good with that? What if I gave you this one then?
Oh, these are the
These
yeah.
are the ones where it's like just
Straight up and down.
Yeah.
Always one is like,
So,
if it's an X, you go straight, and then if it's a Y, you go horizontal.
Yeah, because on the
Yes.
x-axis.
Well, vertical, horizontal.
yes. X is vertical. So this would be straight up and down, x equals -3.
Oh, it's a -3. Dang it.
So you just have vertical line at -3.
Can I go say my email real quick so I can get the beginning?
Yes. Okay.
Emma, that was on the paper. You moved it. Okay, anyways.
So then we have domain and range. So I told you, as long as it's not horizontal or vertical, domain and range are always negative infinity to infinity. Now this one is vertical. So let's look. Domain is the x. As I go from left to right, what x values do we hit?
Isn't x is greater than -3? Would it be? No.
Well,
Oh,
so
wait, no.
the
I'm
only
right.
x value we
is
hit
-3.
is -3. So we can't write that in interval notation because it's not a range of values, it's just one value. So that we just stick with set notation. So you just use, you can just say -3, not 3.
Yeah, we have.
No, I will tell you the Math Excel will have that. So when you get to the Math Excel on the domain questions, it's going to have like A or B. And A will say domain, and it'll have the squiggly brackets, and B will say like domain, and then it would just have an interval. So if it's just one number, you'll have to select the top one and put it in the squiggly brackets. If it's the name infinity to infinity, you do the other one.
Mine look like butterfly wings. So mine look like butterfly wings.
Mine literally just look like little squiggles.
So mine are not that great, but. Okay, range is the y. This is going down forever, that's going up forever, so what's my range? Yep. That vertical line only changed my domain, my range is still the typical negative infinity to positive infinity. It's, if you need to, just draw like 2 circles next to each other. Alright, what about this one?
Except it's horizontal.
Yes. F of x is the same thing as y.
Oh, yeah.
So it's like saying your y is -3. So the domain, my x's, as I go from left to right, what x values do we hit?
All of them.
All of them, negative infinity to positive infinity. The range, our y's, what do we hit? All right, are we okay with graphing lines, domains, and ranges?
Yeah.
Okay, good. Next thing I want to talk a little more about is the slope. So in our graphing, the slope is m, y equals mx plus b. Slope is just a measure of how steep the line is. And we can find it, on the graph we think of it as rise over run. Or if I gave you 2 points, it's the change in y over the change in x. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Okay, what's the slope of a horizontal line? 0. Slope of a vertical line is?
0. No.
Think about your slope dude video. He goes off the edge of the cliff and he yells, undefined?
Oh, yeah.
No, I don't remember. I did not watch that video she told us to watch.
No.
Okay, so one way of thinking about this, does it matter which 2 points on the line you pick to find slope?
No.
So I could pick 2 points. Here's a vertical line. Slope is rise over run. So from here to here I go up 1. I don't go over at all. So it's 1 over 0. That's undefined. This horizontal line, if I pick 2 points, this time I don't go, my rise is 0, my run is 1, so 0 over 1 is 0. So that's something that we might need to make a note of moving forward in case we forget. Slope of a vertical line is always undefined, every vertical line, and slope of a horizontal line is always 0. And again, that's any 2 points on your graph that you might pick. It doesn't matter which ones we use. All right. So let's practice finding slope. So it's just kind of like when we did distance and midpoint, it's just a matter of plugging these things into our formula. So if I gave you 2 points, this is like my x sub 1, so the x of the first, the y of the first, the x of the second, and the y of the second. Are they new glasses?
No.
I would like hurt my head, but if I take them off, then it hurts my head to read. So
It's a no-win situation. Alright. Y sub 2, so negative 6 minus y sub 1, so minus 4. X2 minus x1, so 2 minus negative 2. So I get a negative 10 over positive 4, which reduces to negative 5 over 2. You could write that as a decimal, negative 2.5. I just usually stick with fractions because if we're going to graph, rise over run is easier with fractions. Why don't you guys do the second one? Find that slope for me.
Here, hit the floor.
Yeah, it's kind of obvious when it smacks the wall or something. Alright, so 8 minus 8 over 5 minus negative 3. So we get 0 over 8, which is the slope of 0. What kind of line is that, by the way?
Horizontal.
Horizontal, very good. Okay, we okay with finding the slope from 2 points? What if I asked you to graph the line, but instead of giving you an equation, I just gave you one of the points on the line and the slope of the line? What would we have to do?
Oh, you plug it in. Okay, so y3 equals 4/3 times. You have to find b. Negative 2 plus b.
Okay,
Right?
yes and no. So yes, you guys are writing the equation, but you are way ahead of me. That's next week. I'm not even writing any equations today. So that'll work, and that'll give you the graph, and so that's 100% A-okay. We don't even have to do that much work though, because if I gave you a point on it, yeah, you just start at your point and then you do your slope. Rise over run. Up 4 over 3. And then I've got my 2 points. And draw my line. Alright. Is that line has a positive slope? Is this line increasing or decreasing? Increasing. As you go from left to right, it's rising. In general, that's a good check to make sure your graphs are right. If your slope is positive, your line should be rising. If it's negative, your line should be falling. So that's something you can look at. All right, let's try. I'm going to give you 3 equations and 3 graphs, and we're going to match them without going to all the trouble of drawing the graph for each of these lines. So if I just give you the equation, y equals 2x plus 3. First of all, would that line be increasing or decreasing? Increasing. So which one does it have to be? C. C is the only one that's increasing. All right. All right. Both of these are decreasing, but this one should have a y-intercept of positive 3, and this one should be a negative. So which one has a y-intercept of positive 3? A. And the negative 3 is B. Okay, so we can easily match them.
I was like, why were you writing the letters on that?
Oh, I was doing it under.
I was thinking.
All right. Next little piece I want to talk about, X and Y intercepts. So we've kind of talked about this Y-intercept with our graphing. What is an X-intercept? When you find it, if you're on the x-axis, your y is equal to 0. A lot of times Mrs. Keller would tell you cover-up method. So if you want the x-intercept, you cover up the y and you solve for it. It's just like plugging in a 0 for your y. So a y-intercept is where the graph crosses the y-axis. The Math Excel is going to ask for ordered pairs and all these, so if you're on the y-axis, your x is 0. So your intercepts, your opposite variable is always 0. And then we're just solving. Alright. Got 3 slides left. We're almost done. So let's find x and y intercepts. So x-intercept, it's when your y is 0, or like Mrs. Keller said, cover up your y. So you have negative 3x equals negative 8. Divide by negative 3, so x is 8/3. So as an ordered pair, the x is 8/3 and the y is 0. Am I going too fast on any of this stuff, guys? Alright, y-intercept, that's when you're on the y-axis, so your x will be 0. So it's just like plugging in a 0 for the x or covering up the x. So you get y equals negative 2. How do we write that one as an ordered pair? So now it's your turn. Alright, so x-intercept if our y is 0, we have 4x, cover up the y equals 18. So 18 over 4, which is 9/2. So the point is 9/2, 0. Y-intercept, plug in 0 for the x or cover up the x. So your y is negative 3. So 0, negative 3. Hope we did good on those?
Yeah.
Okay. Last thing, I want to do a couple, like, come on, we can read. It's okay, we can read. In 2006, about 60 billion text messages were sent in the United States. During the next 6 years, text messaging increased, on average, by 407 billion messages per year. So, part A. Find the values for M and B so that y equals mx plus b models the number of text messages sent in billions X years after 2006. Okay? So there's a lot of words here, but we're not really doing much. I want M and B. M is your slope. That's like a repeated thing. The key for slope, think about when we find it, we divide. So it'll be something per something. So if you look for that per, you probably find your slope number. So I see a per here, so what's my slope? Okay, B is the y-intercept. It's like your starting value. Alright, so my equation is y equals 407x plus 6. We can do that. That's all we did on part A. Part B. Estimate the number of text messages sent in 2012. Okay. So in this, it said X was years after 2006. So what would my X be in 2012? So if we plug in. 25 over. Thank you. And my text messages, my Y is measured in billions. So we wrote an equation and we used it. Wasn't too horrible, was it? Under your pencil pouch. Alright, last one. So in 2001, DVD sales were 12.7 million. In 2006, the sales were 19.8 million. Find the average rate of change. Average rate of change is just another word for what? Slope. And to find slope, we need two ordered pairs. So we need to write two ordered pairs from this. So my first ordered pair, we have the year is 2001. And that was 12.7.
Wait, why would we do
You could set it up either way. For the slope, it's not gonna matter. Oh.
Alright.
For writing or for getting the slope, it'll work out the exact same number either way. Then in 2006, it was 19.8. So slope, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Oops, 7.1, not 2. Over 5, 1.45. You guys trust me?
1.42.
1.42, yes, thank you. And if I wanted to put units on this, the top of this, my y, 12.7 and 19.8, they were measured in million. Per the denominator, 2001, 2006, what were those? So it went up 1.42 million per year.
Do we need labels for our homework?
There's going to be like a couple multiple choice questions, and so you'll have to watch those units there. Okay, so here's the deal. There is a Math Excel assignment for this. If you look at this assignment or look at the board, it is not due until Wednesday. Alright, so a couple things I want to mention. The Math Excel, you're graphing on here for the first time, so I figured you would probably need a little bit more of my help, so we're doing more in-class time for this. So trying to figure out how to type that stuff into the Math Excel. So we will have the rest of class today, which we have a good amount of time left. Don't have school Monday. Tuesday, we'll do a little bit of review stuff at the beginning, and then you have more class time to work on it. So you don't have to work on it over the weekend, you'll have class time.